Welcome students, we are expected to evaluate this integral 0 to pi over 4 sin x positive cos x divided by 9 positive 16 times sin 2x times dx. Now this particular question has been approached by different people using different methods, but I am going to approach it in a different manner. So foremost, what I wish to do is I would like to take I to be equal to integral 0 to pi over 4 sin x positive cos x over 9 positive 16 times sin 2x times dx. Now I would like to make the substitution as follows. So that substitution is, let sin x negative cos x be equal to u. In other words, let u be equal to sin x negative cos x. Now if I were to differentiate sin x, I would get cos x. If I were to differentiate cos x, I would get negative sin x, and these two things have to be multiplied by dx. So on the left hand side I would get du. Now this can be rewritten as cos x positive sin x times dx. On the left side you get du. So clearly you can see that sin x positive cos x times dx can be replaced by du. Now the next is the denominator. So we got in the denominator 9 positive 16 times sin 2x. I'm going to rewrite this as 9 positive 16 times sin 2x. I'm going to rewrite it as 2 times sin x cos x. Now we all know that a positive b raised to the power of 2 is a squared positive b squared positive 2ab. If I were to take in place of a sin x, in place of b cos x, and raise it to the power of 2, I would get sin squared x positive cos squared x positive 2 times sin x cos x. So I am having 2 times sin x cos x, but the only thing that is coming out additionally is sin squared x positive cos squared x. Now we know that sin squared x positive cos squared x is 1. So we now have 1 positive 2 times sin x cos x. On the left hand side I have sin x positive cos x raised to the power of 2. Now if I were to represent 2 times sin x cos x using sin x positive cos x raised to the power of 2, the only thing that I should add additionally is to get rid of this positive 1. So if I were to have a negative 1 here, then this entire thing is going to be represented as sin x positive cos x raised to the power of 2 followed by a negative 1. You follow me? So of course when I add negative 1, it is understood we are having a negative 1 on the left side also. But that is not of any importance to us. The only thing that is important to us is how exactly I can rewrite 2 times sin x cos x as a sum of sin x positive cos x raised to the power of 2 followed by a negative 1. That is the catch there. So all these things are for your understanding. You don't have to use them or show them in the problem as a part of the solution. So this is for your inferences alone. So now what I'm going to do, I'm going to rewrite this as 9 positive 16 times. So let me place a square parenthesis. So this is going to be sin x positive cos x raised to the power of 2. So I would get a sin squared x positive cos squared x. So I need to get rid of that. So that's going to be negative 1 there. So this is nothing but this. I hope you are able to follow that. Now, if you were to see the substitution, you can have a look at it. So we started like this. Let u be equal to sin x negative cos x, and we are now having sin x positive cos x raised to the power of 2. Now, I want to make sure that I am having a u here. So what I want to do is, I would like to rewrite this. Let me just so the idea is I'm having sin x positive cos x here, but I have made a substitution as u is equal to sin x negative cos x. So I need to have a sin x negative cos x here. So let me just place a sin x negative cos x. Right? Now if I were to place a sin x negative cos x and raise it to the power of 2, I would have here sin squared x positive cos squared x, but I would have a negative 2 times sin x cos x. Right? So to counter this negative sign, I will have to place a negative sign over here. So that would mean I can clearly have a positive 2 times sin x cos x. Of course, when we have a negative sign here, so what happens? The entire system has a dynamic change. So what is the dynamic change? Though internally, let me show you this. This is going to result in 1, and this is going to be giving me 2 times sin x cos x. So if I were to remove the parenthesis, this is going to be a negative 1 here, but I need to get rid of this negative 1, so I need to place a positive 1 here. So that is the change that we would have to adopt. Of course, I need not have to have started with a positive b raised to the power of 2, but that is just to make understanding a little bit systematic. So what have we got here? I'm going to rewrite 2 times sin x cos x as negative of 1 negative 2 times sin x cos x, right? Positive 1. So this is going to be negative 1, and this is going to be giving me positive 2 times sin x cos x. So negative 1 and positive 1 can be cancelled. So this is going to be rewritten as negative of sin x negative cos x raised to the power of 2 followed by a positive 1. So this is what we need. So what am I going to do? I'm going to take this and I'm going to place it over here. So let me just use the space here. So this is equal to 9 positive 16 times parenthesis negative of sin x negative cos x raised to the power of 2, and that has to be followed by a positive 1. That's it. So now this is the denominator, right? So the denominator is now going to be rewritten as 9 positive 16 times of negative of sin x negative cos x. That's going to be u here. So I got a u that has to be raised to the power of 2 followed by a positive 1. So this can be rewritten as 9 negative 16u squared positive 16. You add these two together, you get 25 negative 16u squared, which is my denominator. So we could have reduced some steps, but just to render a proper understanding, I have just given the steps in detail. So now we will have the integral as, therefore, I, which we started as 0 to pi over 4, sin x positive cos x times dx is divided by 9 positive 16 times sin 2x is rewritten as, I'm not going to alter the limits as such now. So sin x positive cos x times dx, this is going to be sin x positive cos x times dx, this is going to be du, so we can have the du there, divided by this denominator is going to be 25 negative 16 times u squared. So this is what we've got. Now we will have to change the limits for u. Now we started as, let u be equal to sin x negative cos x, right? So when x is equal to 0, what happens? This goes off, and x is equal to 0, this is going to be 1. So let me write that down. When x is equal to 0, this is going to be 0 negative cos of 0, which is going to be negative 1. So my u is going to be negative 1. Now when x is equal to pi over 4, so what happens when x is equal to pi over 4? This is going to be sin pi over 4, it's going to be 1 over root 2, negative cos pi over 4, 1 over root 2. This is going to be 0. So you get a 0 there, right? So now from the law of integrals, I can revert the integral and place a negative sign. So let me just have the negative sign taken out. So du divided by, if I were to take the negative sign out, this is going to be 16u squared negative 25. So this is what I've got. Now let me place the limits negative 1 to 0. Now I'm going to flip the limits. So this is going to be 0 to negative 1. The negative sign gets dropped and we are going to have du over 16u squared negative 25. Now I can take 16 out. So if I were to take 16 out, let me rewrite it like this. If I were to take 16 out, this is going to be 16 of u squared negative 25 over 16. This is what I've got. Now I actually reverted the integral mainly because I wanted to use this formula, which is as follows. Integral dx over x squared negative a squared is equal to 1 over 2a ln of x negative a divided by x positive a, positive arbitrary constant c. So because I wanted to use this formula, I performed the flip. But you don't have to do that, right? So you can just simply take it as integral negative 1 to 0 and then move on. I will also show you that way. So in this case I have performed the flip, so it's going to be 0 to negative 1, and I will have to first rewrite this in this following fashion. So 16 I can take it out. So this is going to be integral du over u squared negative, this is a squared, so I'm going to write it as 5 over 4 raised to the power of 2. So this is equal to 1 over 16 and 1 over 2a, so it's going to be 1 over 2 times my a is 5 over 4 times ln of modulus of my x is u negative 5 over 4 divided by u positive 5 over 4. Of course, the limits are 0 to negative 1, so we will have to place the limits. So before we could place the limits, I would like to make the substitution. So I will just simply place the parenthesis and probably some limit a to b. I'm not going to use the limit as just now. So this is equal to, now if you were to flip this, right, now 2 can divide 4 2 times, so if you were to flip it, this is going to be 1 over 16 and 2 over 5 times ln, right? So ln of, I can now simplify this, so it's going to be 4u negative 5 divided by 4u positive 5. Of course the 4 will get cancelled. So the limits are 0 to negative 1. So 0 to negative 1. These are the limits. Now 2 divides 16 8 times. 8 times 5 is 40. So this is going to be 1 over 40. Now we will have to place the upper limit. So this is negative 1. So ln of 4 of negative 1 negative 5, there's a modulus sign here, divided by 4 of negative 1 positive 5, right? This is the upper limit minus the lower limit. So negative ln of modulus of lower limit is what? 4 times of 0 minus 5 divided by 4 times of 0 positive 5 modulus. So this is what we have got. So this is equal to 1 over 40. Now ln 4 times negative 1, negative 4. Negative 4 added with negative 5 will give me negative 9, right? So this is inside the modulus. So modulus of negative 9 divided by 4 times negative 1, negative 4 added with 1, that's going to, added with 5, that's going to be 1a. So this is the first evaluation, followed by negative ln modulus of 4 times 0. So I will have a negative 5 here. 4 times 0 positive 5 here, right? So this is what I have now. Now 5 divides 5 one time, I have a negative 1, but it's a modulus sign, so I'm going to produce ln 1. So ln 1 will be 0. So that goes off. Now ln of negative 9, but it's present inside the modulus sign. That's going to be 1 over 40 ln of 9. Now if you want, you can rewrite this as 1 over 40. Ln 9 is 3 squared. I know a formula. Ln of a raised to the power of b is equal to b times ln a. It's a formula. So by that formula, I can rewrite this as 1 over 40 times 2 times ln 3. 2 divides 40 20 times. So it's going to be 1 over 20 times ln 3. So this is a good place for us to draw the red line. As I mentioned to you, I have just made one thing which is not in the order of conventions, right? But I have done that mainly to utilize this particular formula. You can either use this formula or you can simply retain the same limit and decompose it by partial fractions and still get the solution. So that is a good place for us to stop, students. Thank you.